Hello everyone, welcome back to this new Python video. This is going to be my third video in Python data type series. In this video I will discuss about tuples and sets. In the last video I discussed about lists and some of the important methods and functions that we have. And in this video I will discuss the same about tuples and sets. So let's start with the tuples. Tuples are kind of exactly same as lists, except only one thing, that lists are mutable. That means once the values are there, we can add more values, we can remove values, we can change the values. But tuples are immutable. Once the values are there, we cannot change them, we cannot modify it. So you can say it's like read only version of the lists. The other properties of tuples are same as list, like insertion order is preserved, duplicates are allowed, heterogeneous objects are allowed. If we want to access the values, we can use both positive negative indexing, and also we can use the slicing. So to give you the example that tuples are immutable, let me first create a tuple. So how can I create a tuple? For example, I can just enter some values, and if I want to print this and I wanna print type of this, then this is a tuple. So this is one way of creating a tuple. So now I have a tuple t in which I have these three values, and I want to change first value to, suppose you can say, 88. Here after doing this I will get the error that tuple object does not support item assignment. So this means we don't have any such properties available to us with which we can modify the values. That's why it is immutable. Once it's created, we cannot change the values. So yeah, other properties are same as lists. I have already given their examples in my list video. If you wanna see them, you can refer to that video, but I don't think there is need for me to go over them again. For the tuples, they are exactly same as lists. So yeah, let's see how we can create, like what are the other ways available to us to create a tuple. So if I want to create a tuple with only one value, one integer value, if I do like this and I will try to print the value and again the type of t, then I guess everybody knows that it's an integer. And if I want to just create a tuple with a single integer, what I can do, I can just pass comma after that. This is the way to let Python know that we want to create a tuple. After passing the comma, Python will know that this is a tuple. So this is one way of creating a tuple. What's the other way of creating a tuple? Suppose I have a list like 10, 20, 30. From this list I want to create a tuple. So what I can do like t is equal to tuple of L, and I will do print t. It's only 30, so let me put more. Here I can create a tuple like this, and suppose I have some range of values, with that also I can create a tuple. For example, like I have t is equal to tuple of, I want to create for 0 to 10, and I want to print this, then this is a tuple. So these are some of the ways available to us to create a tuple. How can I create an empty tuple? Just by like passing like this. So now this is an empty tuple, but I don't think there is going to be ever a need just to create an empty tuple, because we know that it's immutable. So we don't have any property to add any elements or remove any elements or append any elements. So even if you try to do it, you will get an error. So there is no point of just creating an empty tuple. It's not going to be in need, I guess. So yeah, so I have created, so now I have this tuple, and for that tuple I want to, you can say, suppose use slicing operator on that. So how can I do that? I can just do like print t of 1 2 3. it will just give me 1 and 2. So this is 0, 1, 2 and 3. So 1 and 2, it does not include, I guess everybody knows it does not include the last element, or you can say the last index that we have in our slicing. And after that, the other properties that sets have is the, let's talk about the mathematical operators that we have. So suppose there is a tuple in which I have 10, 20, 30, 40 and 50, and in second tuple I have like 30, 40, 50, 60, 70, and I want to add these two tuples, T1 plus T2. Here I can see that I got all these values 10, 20, 30, 40, 50, and then 30, 40, 50, 60, 70. So while doing this, it's not making changes to either of these tuples, so it's a totally new, you can say, the value here. So T1 and T2 are still same. So don't think like by adding this we made the changes and now here it's contradicting that it's not immutable. After doing this, it's totally a new different value, and we can see it here, like when I do T1 it's still 10, 20, 30, 40, 50, and here we can see that it has duplicates and orders are preserved. So I just showed these other two properties, like duplicates and insertion order is preserved. So now this is one of the mathematical property. The other mathematical property is like the multiplication. For example, if I want to do T1 is equal to T3 is equal to T1 asterisk 4 T3. Now my T1 is 10, 20, 30, 40, 50. It's going to be repeated 4 times. We have already seen this in lists also. So these two are the mathematical properties that we have for tuples. The other properties are length. I guess everybody knows how to do length. It's same as list. So here I have 20. It is 5 here, I multiplied it 4, so 20. So this is length is 20. Again I have the property of count. If I wanna count 10, I wanna count 10 on where? On T3. It will tell me how many times 10 occurs in this tuple. It occurs 4 times. And same, I can use the index also. I can do like T3 dot index of suppose 40. Here 40 is at third index, 0, 1, 2, 3. Yeah, so 40 is at third index. Next property is going to be sorted property. It's same as this in the lists. For example, I can do like print sorted of T1. It was already sorted, but yeah. And here we can see that once I did it, it is returning me the list. It's not a tuple. So after applying sorted on a tuple, it is going to return the list. For example, here I created a T4 is equal to 0, 20, 8, 11, 5, 90, and I want to sort this out. Here I can see it's 0, 5, 8, 11, 20, 90, but it's a list. Again I can apply tuple on it and it's again going to be in a tuple format. So after applying sorted on a tuple, it is going to return the list. I have other operators like min and max. For example, if I wanna do min in my T4, minimum value in my tuple T4 is 0 and maximum in T4 is 90. Other than min and max, I have properties of like Comparison operators like equal to, not equal to, less than, greater than, those are also same as the lists. You can refer to previous video for that. One important thing that I want to discuss about tuple is the tuple packing and unpacking. For example, I have like a is equal to 10, b is equal to 50, c is equal to 90. For that, if I want to create a tuple, what I can do like t is equal to a comma b comma c. I guess everybody knows this as I explained this before. And if I want to print t, here now I have a tuple with these values 10, 50, 90. So this is like a packing concept. So I packed all those values and tied them with t to create a tuple. So same way I have the unpacking concept. For example, in my tuple I have 100, 88, 73, 25. I have these 4 values in my tuple and I want to unpack this. What I can do like comma b comma c comma d is equal to t. So now I assigned these 4 values to my t, where a first value will refer to the first value of my tuple, b will refer to the second value of my tuple, same for c and d. For example, if I want to print d, it is going to be 25 because here d is at the 4th and it's referring to 25. So this way I can unpack a tuple. And for example, if I have the same tuple here but I have more values like 63, 99, 102, I have these many values and I don't like, suppose I don't know how many values are there. What I can do, I can refer to like a comma b comma c. I just know that 3 are there for sure, and rest if they are there, then I can just do like this. Oops, not like this, like this. So here I am saying give a the first value, b the second value, c the third value, and whatever the rest of the values are available, give it to t. For example, if I print a and if I print c and if I print d here we can see that a is 100, I can see a is 100, c is 73, c is 73, and d have all the other values that are there. So 25, 63, 99, 103, they are in D and they are as a list. So this way the packing and unpacking works for tuple. I guess this concept is going to be one more time when we are going to discuss about the functions. So this is like args and quarks. This like, that's how we use them in the functions if we don't know how many keyword arguments or number of arguments are there. So this is all about tuples. Let's talk about sets now. So sets are little bit different. They are like, sets don't allow duplicates. So there you can say there are always going to be the unique value in the sets, and order is not important. So it can, you can say, randomize the order of the values within the sets, and if the order is not there, then that means we cannot perform the slicing and indexing, because we don't know at which position which element is going to be there. If we don't know that, then we cannot perform the slicing and indexing operations. Other than that, heterogeneous objects are allowed, and sets are also mutable and growable. For example, not so how to create a set. To create a set, a blank set, what I can do like this. If I do print s, this is a way to create a empty set. So this, you can say this is class set. So this is a way of creating an empty set. And if I know the values within a set, how can I do that? I can do s is equal to set of 10, 20, 30, 40, 50, 60. Print s. Oops, it is going to be like this. Yeah, so this is the way to create a set. 50, 20, 40. And here suppose I want to have the duplicates. So 10, I want to put 10 again, 10 again, 10 again, 20 again, 30 again, and then I have 90. I have duplicates here, and let me try to print the set. Now we can see that the positions are changed because order is not important, and it has removed the duplicate values. All the values are only available once within my set. So set will not let you keep duplicates within it. So that's how we can create a set, and we saw that order is not important, and also it doesn't allow the duplicates. So suppose I have an empty set s, and I want to do like s dot add 100, and I will print s. Oh yeah, so I have this set, and I have this property of add, with which I can add the value within my set. I have not mentioned where it is going to be add because order doesn't matter, so it will add anywhere. So next time if I do like s dot add 100,000, and I will print s. Now this is here, so it will add values randomly at any position. So this is one property, add. The other property is going to be update. So how update is different from add is, in its update it says that it's iterable, so it has to be some sequence. For example, like I wanna add like range of 0 to 15 step 2, and I wanna add range of 100 to 190 step 10, and then yeah, I want to add these values, print s. So in update I am using first value is range of 0 to 5 and then step 2, and second value is range 100 to 190 and step is 2. So when we do update it so the values must always be the sequence, like list, range, or something like that, and that's how it's adding the value. Order doesn't matter, so it's just adding the values at random positions. The next property is pop. So I will do s dot pop. It will remove some random element and it will return that value to me. So here it removed 0 and it just returned 0 to me. Okay, let's remove this time. This time it removed 2, 130, 4. Okay, so it's removing, it's in order. Does order matter here? And now if I do s dot pop again, 10. Okay, maybe it's happening just now, but yeah, it just remove the value and return me the values that it's removing. And suppose I just keep on removing the values, yeah, whatever. So I cannot remove all those values will take a lot of time. But yeah, so if after removing everything, if it's an empty set, then it will not work on the empty set. I guess everyone guessed it, because if it's an empty set there is no value to remove, so it cannot return anything, so it will throw the error. So next property is remove. If I do s dot remove of what element I want to remove, suppose I want to remove 110, So it will find that element within the set and then it will remove that and we will get our set back. So this has to be an element. Suppose I want to remove an element that's not here. What's going to happen? The set doesn't have this value, so that's why it cannot remove it. So it will throw us the error. And other property is discard. S dot discard. I will do the same for the discard. I will put some value that's not here. I want to remove this and I want to print S. So that's how discard is different from remove. In remove, if I am putting some value that's not in my set, it is going to throw the error. But in discard, if I will put some value that's not in the set, it will not throw us the error. It will just not remove anything because it's not in the set, and it will just return us the set. It will not return I'm getting it because I'm printing it here, but yeah, it will not throw us the error. So that's how discard is different from the remove. Next property is clear. If I do s dot clear, I guess it's pretty much clear that what's going to happen. It will empty our set and now we have a blank set. Yeah, clear will clear all the elements from our set. Next property or the things that I want to discuss is of the mathematical operators. For example, I have a set S1 is equal to 9, 8, 7 and S2 is equal to 4, 5, 6, and I want to add the sets. S3 is equal to S1 plus S2, print S3. Here we can see that on sets addition doesn't work, it will throw us the error. It's obvious, like it will throw us the error. How it is going to add? Because it doesn't know, you can say, the order or anything like that, so there is going to be an error. If I try to do same thing that we did for our tuples, like multiplication operator, what's going to happen? Again there is going to be an error because it doesn't support this. So these two properties are not available for sets, what we have for tuples and lists. But there are some different properties that are there for sets. For example, one of them is union. For example, if I keep it here 9, 8, 7, 6 and 5, and here I will do like 3, 2, and I wanna do the union. So S1 dot union of S2. So what union do? It will just, as I think everybody must have studied that in the mathematics, it will just get all the values that are there and will remove the duplicates. So now we have 2, 3, 4, 5, 6, 2, 3, 4, 5, 6 and 7, 8, 9. So 6, 5 were there 2 times and they are only here once. So it will get all the elements that are present in S1 and S2. So that's what union do. Next is intersection. In intersection, S1 dot intersection of S2, what's going to happen? It will just return the common values that are there. It's like S1 intersection S2 is like only the common values that are present in both the sets. Next property is difference. What will difference do? It will just return the values from the one that are not there in the other. Difference S2. So here S1 dot difference S2. So I am just getting only those values from S1 7, 8, 9 that are not present in S2, In S1 I have 6 5 also, but they are present in my S2, so I will not get those values. If I do the opposite on not on like S1, what values will I get? I will get only 4 3 2 here, 4 3 2, yeah. So this is difference. Next one is symmetric difference. In symmetric difference, I will get only the values that is not present in both of them. For example, S1 dot symmetric difference of S2. Here I am getting 2 3 4, 2 3 4 and 7 8 9, 7 8 9. So what are the common values? Common values are 6 and 5. So it will just remove the common values and will just return me the values that are present only in S1 and only in S2. So whatever are the common values, it will remove those values and I will just get the common values. So that's how the symmetric difference works. So these are the 4 unique properties, or you can say methods, that we have available for sets. The others like in, not in, membership operators, they are same as lists and tuple, so I don't think I should discuss them here and just increase the length of the video. But yeah, these are the some of the important functions and methods that we have for tuples and sets. In the next video I will discuss about the dictionary. Dictionary is like very important other than lists, so it is again going to take a lot of time. And after that I will discuss about the comprehension, list comprehension, dictionary comprehension, and about that. So yeah, hope this video was helpful. I will keep this video until here, and in the next video we will discuss about the dictionary. Until then, take care, have a good day, bye.